with Dr. Satya Gupta. Dr. Satya Gupta is a fellow BITSIAN and also an IIT Delhi alumnus and a techno-visionary in the field of semiconductors. He has over 3 decades of experience in semiconductor design, and he is very well connected with the academia, government, and also plays an influential role in policy making. He was the director of ASIC design in Intel Microelectronics and has co-founded 5 startups. Currently, he is the president of VLSI Society of India. Sir, we are truly honored to have with you today. I'm going to let you take over from here.
Thank you, Kush, and thanks everybody for joining on Saturday evening. Uh, I joined BITS basically as an 18-year-old in 1983, which is almost like now 50 years. Uh, uh, or- uh, so it has been an exciting journey. Came to BITS as a basically the last 5 year batch. Uh, Joined from a completely Hindi medium school, and when I joined, I probably hardly could speak 2 sentences in English properly. And but through the years, working through basically various opportunities which came my way, uh, trying to basically contribute to the field of electronics and semiconductor. So I'll just give 5 minute context that what are we doing, especially in India in the field of electronics and semiconductor, and then we will basically have a interactive session with all of you, right? So I think the way I perceive any particular technology domain, I think the products in that particular domain basically define vision, right? Uh, for example, if you think of Japan, you always think of Toyota, Honda, and the type of the cars they make, or basically companies like Monio, Nikon, which make basically electronics or the camera gadgets, right? I think that basically, in a sense, define that particular country. So if we look at the field of electronics and semiconductor, right? Today, there won't be any field of our day-to-day existence which is not touched by basically the gadgets which are basically built using the electronics and powered by semiconductors, uh, and the technologies underneath, things like IoT, cyber physical system, 5G, 6G. uh, Typically, basically, when I interact with young fellow from the field, right? In a day, probably we end up using more than 100 chips, knowingly or unknowingly, right? That's how pervasive this technology has become, and not just for the citizen. I think today, a country cannot be called developed or superpower if they don't have electronics and semiconductor capabilities at the highest technology level. So, if we just look at the impact of this technology, you see by basically in next 2 years, uh, we will reach almost $400 billion of consumption of the electronics products in India. And that is because the young and aspiring society is basically driving overall economy. And you can see first trillion basically we took 67 years, second trillion we took 7 years, and third trillion we could achieve in 3 years. And I think the fourth trillion probably be about half of that, about 1.5 years, right? So now if you look any domain, if you want to achieve the self-reliance, and especially in the field of electronics and semiconductor, it has to be driven by the products, both electronics products like mobile phone, laptop, TV, any of the electronic gadgets, which are in turn powered by the chips and the integrated circuits, which give them the power, compactness, and feature richness to these products, right? Obviously, once you design the products, we need to have the manufacturing capability, which basically taking one particular product and producing it in masses like millions. Again, both electronics and semiconductor. In the electronics, we call it contract manufacturing, and semiconductor, it's the semiconductor fabs and ATMP. And then it has to be very well supported with the research and the talent development, which will work for towards the product development and manufacturing to make this whole ecosystem a complete and vibrant ecosystem. So, what are we doing in India to support and grow all these three pillars of the electronics and semiconductor industry? So, some of you might have heard the name of PLI, which is Production Linked Incentives, and India
Noted.
Semiconductor Mission. PLI is more for electronics product manufacturing, and India Semiconductor Mission is driving the semiconductor manufacturing. And together, between the two areas, government has put about $30 billion of incentives to make sure that basically we produce the global class products out of India and basically not just serve the domestic demand but also export these products to the rest of the world, right? Uh, for the product development, uh, there are basically schemes like future design, where about $150 million, which may basically soon be moved to about $1 billion to develop the products. Like if you somebody wants to develop a mobile phone, or somebody wants to develop a basically a AI/ML device to help the automobiles, right? So product level development and research, and third is basically research and talent development. There, the government has schemes like Chip 2 Systems and Indian Semiconductor Research Consortium. Uh, so overall, basically, if you look over the next 10 years, India might basically provide incentives approximately of about $50 billion, uh, which is basically 40,000 crores. And the return of investment, not it will be about basically 5x of that, but more than the financial returns, I think these technologies has become so strategic for the country that your defense, your infrastructure, your basically economy, everything kind of start depending on this thing. And not having these technologies will be a basically a big disabler for a country with the growing aspirations of India. Just like 30 years back, whatever the status, space, and atomic energy used to hold, that any country used to have it, today the same status is held by semiconductor and electronics, right? So, I think for semiconductor development, we had two very large international events by the government of India called Semicon India 2022 and 2023. And I think this was basically invitation to the world to work and collaborate with India to develop and proliferate these technologies so that India can get the well-deserved status in these technologies. So I think it all depends on the young guys. Where do we go from here? Uh, and let's hope that a lot of you will join the bandwagon of making India electronics and semiconductor product nation. Thank you, and now we can get into interactive session.
Thank you so much, sir, for all that information. I hope that everyone gained something from it. Uh, moving to that particular slide that he showed, that maybe we will achieve the 4th trillion in a year and a half, and so all of us know that India is aspiring to become a 5 trillion economy by the end of this decade. And I also saw you mention somewhere that India's semiconductor industry is growing at a CAGR of 20%, which is 4 times more than at the world's pace. So how significant of, or how large would be the contribution of electronics industry in the coming 5 to 10 years? How big a
So,
share it will hold of the of our economy?
so by the time basically India reaches the $5 trillion economy, which we are expecting about 2030, right? We
Yeah.
expect that the overall electronics consumption or the size of the market for electronic industry will be about 10 to 15% of basically that 5 trillion, which is about 500 to 600 billion dollars. We will reach by the time India reaches the $5 trillion economy, or number third economy in the world, right? Those are the aspirations. So I think it has to be somewhere between 10 to 15% of overall economy size.
Wow, that's mighty big. Sir, upon researching, uh, I found out how in the 80s and 90s, India was booming with a lot of electronic product companies. Can you can you put some light on what went downhill? And also, now that we are stepping in back to the game, Minister Rajiv Chandrasekhar has said that India has the potential to achieve what China did in the past 30 years in a matter of 10 years. What steps do you think we should take in order to drive this ambitious challenge?
Okay. So uh, when I was basically in the college, passing out in 1983, right? And so at that time, a lot of electronics companies are there making televisions. Some of them have started basically making the microcomputers based on Intel 8086 or 8088 processor, right? Uh, but the way basically the geopolitics of the electronics went from there, there was a period where basically most of the electronics brand and electronics companies basically suffered and slowly closed down, right? But if I take last 10 to 15 years, right,
Yes, sir.
government has understood that we have to provide the right incentives, not a protectionism, but right incentives for the industry to start manufacturing the electronics products. And once we have the foundation of the manufacturing, then we can basically take this infrastructure and know-how and the people and start converting basically the manufacturing infrastructure to a basically product economy.
Yes, sir.
Uh, so we are in that journey. China took about 30 years to get there. We hope to basically achieve the same in about 15 years, half the time. I think on the manufacturing side, last 10 years have been very good. Where basically, if everybody likes to take the mobile as an example, right? So today we make means let me qualify it properly. We manufacture almost all the domestic demand and some export of the mobile phones in the country, and the
Yes,
same
sir.
is true for other electronics products also, right? Uh, so the manufacturing is strong, but if we see what we manufacture today, we are manufacturing primarily for the global brands.
Yes,
As
sir.
you said that Indian brands have basically suffered over the decades, right? So I think the next step we have to do is that taking this fantastic manufacturing infrastructure which has been built and now create our own products, our own brands, and that's the message basically which I'm trying to convey through my discussion with a lot of students that now the manufacturing we have a good handle. Now let's move to make basically India as a product nation. In next 5 years, I want to see five mobile phone brands coming out of the India. You guys already probably almost all of you use the boat uh, devices for your headset and other things, right? We need more companies which can create brands and products which are designed in India. That will give the real self-reliance to India, and that's how we are going to catch basically countries like China. That from manufacturing now we have to move to products.
Yes, sir. Sir, going back to the point where you said everyone talks about examples of phones being manufactured in India on a large scale. Uh, I looked into that, and as you said, we are producing it for the global companies, that we are importing those component kits and then making the product. How can we ensure that the Indian companies, whichever present today, increase their purchasing from the MSME traders who are manufacturing components in India?
See, once you start designing your own products, right? The first thing happens is that you have the decision power to choose the components from wherever you want, right? If you are
Okay.
if you are manufacturing for let's say Apple, then Apple decides sitting in Cupertino that what components to buy and where to buy them from, right? Once you start doing your own designs, then first thing happens is that you can make a decision where to buy these components and basically how to procure them. Maybe initially these components like high-end semiconductor processors, memories may or may not be available from the Indian companies, but at least you have the decision power, right? Once you get the decision
Yes.
power, then you can basically slowly convert it to basically wherever it is available at best possible cost, right? To buy it from there, right? So the first step towards basically using your own component ecosystem is to start designing the products from India with Indian brands, not just basically designing or manufacturing for the world, designing for Indian company for Indian brands, right?
Okay.
And things like Tejas Network, Boat, Noise. I think these guys are doing good work, but they need to convert it to more basically India-based design, right? So, and hope basically they continue on this path and succeed in their endeavor to make India designed products.
Okay. So what you are saying, that the key to generate a component system is to start designing in India and for India.
Yes. But then you have the control, right?
Yes. So now going back to the dilemma of manufacturing versus design, a lot of people have said that a semiconductor chip plant today requires 24 hours of electric and water supply, a spick and span around spick and span surroundings. That there may not be a lot of optimum locations in India to support that plant. Sir, also in the on, are we self-sufficient today to manufacture on a large scale?
See, whenever people talk about semiconductor manufacturing and they talk about the things like infrastructure, water, electricity, I think these are basically discussions which were meaningful 20 years back, right? In today's India, getting the water, getting the electricity, getting the right basically clean and span environment it's basically no brainer. We can do it anytime, right? Now, the other part of the semiconductor manufacturing is that ultimately it's a business, right? So a semiconductor fab is successful if it is all the time 90% plus utilized, right? What we call as a utilization factor, right? In the industry. For that, we need to have the customers who are ready to buy your wafers, which we are going to produce from this semiconductor factory, right? I think that in my uh, uh, based on my basically understanding, that's much bigger challenge than getting water and electricity. I think uh, we have done basically so many large projects across different sectors that water, electricity, road, building, clean room. I think they all are basically very, very, very doable, right? I think main thing we
Okay.
should focus uh, to get the right technology, right investment, right team who is driving this business, and the customers who can make the utilization of these factories whenever they are ready. If a semiconductor factory cannot be commercially viable if it is not basically 90% plus utilized, right? So that is a very, very big factor. I think the infrastructure problems in the new India, I think people should not even bother. They are all solved problems.
Okay. That was something I didn't know about. It was particularly new for me. Uh, Moving on, sir. Uh, while upon reading, I also found out about the design link scheme, that how the government has brought in all the softwares from Cadence, and it is assisting all the designers who want to, and it is very good for designers who want to design right away and who do not have enough resources. Sir, what are such other schemes that we don't know about? Because from what I find out, design link scheme was something which was really great, but it may not be all people may not be aware of it. And what can the government do so that all everyone is made aware of it?
So let me first explain the design link incentive scheme, which uh, government of India brought about basically year back, right? Uh, so design link incentive scheme is to enable semiconductor product companies, or what we call a fabless companies, which make the semiconductor products and they utilize basically factories world over to basically manufacture those products, right? So
Yes, sir.
companies like Qualcomm, Broadcom, Nvidia, AMD, all of these are basically iconic examples of these kind of the companies,
Okay.
right? Yeah. So none of them have basically their own semiconductor manufacturing plant. They develop the products, take it to the point where basically they are ready to manufacture. Then they send it to factories like PSMC and other places. They manufacture, give it back to them, and then companies like Qualcomm sell it in the market. So to develop that type of the company, government came up with this design link incentive scheme, where 50% of the project cost. So typically, if it takes $5 million to basically design a uh, medium to low complexity chip, right? Then
Okay.
half of that will be reimbursed by the government. That's the first part of the DLI, right? Then second part of the DLI is this EDA tool software, what you mentioned from Cadence, Synopsys, Mentor Graphics, all of these guys, right? Siemens. Uh, those software which are typically about 15% of the cost of the project, right? So if a $5 million was the cost of the project, 15% of that will typically go in
Will
buying
be
this software. So that is also free. So 15 plus 50, now you got 65%. So two-thirds of basically your project cost is reimbursed by the
by
government.
the government.
No, basically they are not asking any equity, they are not asking any repayment of these things. If you qualify, For the DLI scheme, you automatically get 50% plus 15%. Now, to make it even sweeter, right? Some of the states, like Odisha, for example, right,
Yes.
is giving 20% on top of this, right?
Oh,
So
wow.
15 plus 50 plus 15, 65 plus 20,
65,
85.
20, 85.
So I don't think anywhere in the world there are incentives like this available for the semiconductor product company or the fabless product company. So that's what is happening. And I think the whole motive and the intent of doing this thing is that a chip product company or a startup should be as easy to start as a software company. Like five of you have an idea, you have a laptop, you go to beach or the deserts of Pilani and start coding. You don't need any infrastructure. You
Yes.
don't need basically big capital. It should be as easy as that if you have idea and basically for a good product, then basically rest of it is practically covered by the government. Uh, yeah, obviously your idea has to be good enough to bring in the another 15-20% of the money from basically investors or angels or anybody like that. But I have not seen basically such a powerful scheme anywhere in the world.
Oh, okay. I think all of us here would be surprised by the incentives the government is providing today. Moving on, sir.
So just to build upon it, because you asked for what are the other scheme other than
Uh,
DLI, uh,
uh,
for the students and academic institutions, there is another scheme C2L by the government, where government has chosen about 103 institutions across the India, and they will provide the basically complete infrastructure to them and funding to basically first thing is the train people for this particular area, okay, and also basically convert some of the ideas in the academic institutions to startups. So that's the scheme number two, right? Uh, Third is basically after many years, right? BITS has its own basically system, but typically we have the branches like electronics and communication engineering or electronics and instrumentation, and these things have not changed over basically almost 15-20 years. So I think last year a undergraduate program in electronics and VLSI was approved by AICTE,
yeah.
and about 125 institutes they are planned to start this program from this academic year or next academic year to bring the VLSI education at the undergraduate level. Earlier, it was primarily taught as a degree program only in the MTech and PhD program. So now, a lot of these institutions can start teaching it basically uh, at the undergraduate level. And I'm trying to, am I audible?
Yes. Yes. Yes.
Yeah. We are trying to work with the bits also to see how do we bring more VLSI type of the courses at the undergraduate level, either in form of a degree or just basically having a good basket of these courses so that basically people can take the benefit out of it. And when I have the opportunity, we are also hosting a one of the very large conference, VLSI Design and Test at BITS Pilani in collaboration with Siri, end of September. So if anybody you are interested in this field, please join. This is one of the largest conferences in India which happens in this year. So through VLSI Society, we are hosting it in BITS Pilani in collaboration with Siri this year.
That's great to know, sir. Uh, as you mentioned that course which was approved by AICTE, uh, Prime Minister Modi mentioned that as well in the most recent Semicon and said India aspires to have more than 1 lakh design engineers by the end of next 4 or 5 years. So maybe that course which is available to the coming generation would be of benefit to them. But before this talk, I received a lot of questions that as of now, what can undergraduate students who are in triple E, EC, or maybe electrical as such can do to upskill themselves at the undergraduate level and become a part of the industry early on,
Yeah.
and not wait until their PhDs or maybe an MTech.
So, see, this new undergraduate program will take 4 to 5 years to effect because people will join, they graduate, and so on and so forth, right? But today, if we see, there is a demand for about 18 to 20,000 engineers every year,
Yeah.
basically coming from the academic institution or what we call RCGs, right? Okay. And all of that demand cannot be fulfilled with MTech and PhD. It has to come from BTech also, right?
Yes.
Uh, so typically, if you look at the system like BIT, right? If you take about 3 to 4 electives, okay, and I saw Anugupta ma'am being in the audience, right, or basically
Uh,
participant.
yes.
She has tried for some time, right? So I think BITS has a good basket of the courses. It does not take more than 4 to 5 courses to do in things like digital electronics, ADVD, uh, and couple of designs, couple of courses in associate design, and so on and so forth, right? If you do about 4 courses well during your undergraduate program as electives, I think, and in addition, if you can do a project, right? I think that basically will make very successful uh, entry level engineers into any of these basically large companies. And
Yes, sir.
and all of these basically offer very competitive compensation also. So it's not like that basically software gives much higher compensation than basically electronics or VLSI. I think VLSI chip design companies provide very handsome compensation, right? We have done this in the past as part of our previous companies. We used to hire somewhere around 5 to 10 people because we were startups from basically BITS undergraduate stream, and we were very successful basically, uh, and very highly productive basically. People came out of that initiative, right? So I think it's just matter of basically taking 3 to 4 additional courses in this domain. Some of them may be already core courses like digital electronics, ADVD. I think they are anyway core courses for triple E guys. If you take another 2 to 3 courses and do a good project, you are all set.
Okay. That I think that would have answered a lot of students' queries, as it was a very common question among them. So my this is a personal uh, query for me. Everyone today is talking about artificial intelligence and machine learning and how it has uh, potential to basically revolutionize everything that we are doing today, and probably it is doing today in manufacturing as well. Having a PhD in neural networks and such a vast industry experience, do you see bots and computer system designing chips in the future, or still it requires human intelligence? And how do you see the industry integrating these modern tools in the coming years?
First of all, I think a lot of success of AI today is because of the progress we made in semiconductors. Okay.
Yes.
If we stop making the progress in semiconductors, all of these AI models, being large language models, transformers, and others, right? They will not be able to function at the basically the large scale which they need to do it, right? So I think semiconductors have a lot to do with the success of AI today because a lot of basic algorithms in AI they were developed almost 2 to 3 decades back, right? But they could not deliver the result because the computing power was not there.
It was not there.
Yeah. Now computing power is there coming from NVIDIA, GPU, and other basically things, right? So that's point number one. Regarding whether the chip design will be done by the artificial intelligence tools, just like any other field, I think this will be a very useful tool to help basically our designers become more effective. But it is nothing to basically say that it will completely replace the designer, right? That just like software, just like basically any other domain, it will make our engineers more effective, more basically productive, so that we don't end up basically doing mundane tasks over and over again, right?
Good
Basically, I
design.
think the task will be taken over by the AI, but the key design elements still will be very much human driven. It's just like anything else, right?
Yes.
Because uh, when I was in beds, right, and we used to do computer programming. So that time, I don't know how many of you know, we used to do our programming on the punching machines, right?
Yes,
There were no.
my computer instructor told me of this as well. They had to wait for days to find the result.
So you write a program, you give it to the machine to analyze and compile, and if you have made one syntax error, like one semicolon missed, you have to wait for another 24 hours. Right? So now even for software guys, right? Now the compilers came, all of those things make the software much more productive, right? So I think AI is a tool, just like all other tools came before AI, right? To make engineers, programmers, and other people more effective. Uh, I think it can never, basically, at least in the near future, it's not going to replace engineers who are designing chips or who are designing software. It's just going to make them more effective.
Okay, thank you, sir. Uh, Speaking of design and innovation, right now we see that almost all of it is concentrated in the US. In 2014, they created a 14 nanometer 14 nanometer chip, which China achieved in the 2019. And recently, IBM developed a 2 nanometer chip. Do you think that all the information and tech is being monopolized by the US, and it does not share it with the world?
I don't think that's anymore true. Okay. Because if you take the semiconductor technology which you gave example, right? I
Yeah,
think US, Taiwan, South Korea,
South Korea,
Japan,
Japan.
Europe, I think all have basically pretty advanced technology, especially basically Taiwan and South Korea, maybe a little bit even better than basically US in this nanometer race which you talked, right? But all of them are basically doing the fantastic job, right? The largest intellectual property company in the semiconductor is ARM, right? ARM company. It comes from the
Yes, sir.
UK, right?
UK.
Largest semiconductor manufacturing company, which is TSMC, it is Taiwanese company, right? Largest mobile and display manufacturing company is Samsung, which comes from Korea, right? So I think it has already become basically global industry. Some of the equipment which we use in semiconductor manufacturing comes from Japan, Netherlands, Denmark, Dutch, all of these places, right?
Yes.
So innovation is all over the place. Uh, Now, semiconductor product companies, if you see, right now it's uh, dominated by the US companies like Qualcomm, Broadcom, Nvidia, AMD, but I think slowly that also is spreading across basically the globe. So I think at this point of the time, it's nobody's monopoly. Uh, China is doing basically its own bit. Although the geopolitics and the sanctions have put some basically uh, difficulty in the progress in some of the areas, but I think those are the temporary things. It will get sorted out.
Okay. Thank you so much, sir. Uh, that was the end of all the questions that we had collected or researched upon. Now, the audience is free to ask questions to the sir. You may raise your hand one by one, and we'll let you. And we'll. Uh, yeah. Everyone, please wait. Anu ma'am wants to speak something. Anu ma'am.
Uh, yes,
Yes.
yes,
Yes,
I'm
Good
ma'am.
good.
evening, ma'am. How are you?
I'm fine, Dr. Satya. So I'm very fine. It's good to like attend this talk and have a first-hand knowledge of science and information. And we are eagerly here. I'm very much eagerly waiting for it.
Yeah,
So
I'm coming end of September.
uh, I'm actually very eagerly waiting just because not because India will benefit from it. Surely it will be. But as a teacher, I want my students also to get benefited.
Absolutely.
The first question I have that it gives us a lot of like everybody says there would be a lot of opportunity. Our students will have a like there would be a lot of opportunities in this field. But still, I think there is some time before we can bring that work culture into India. It will still be some. It needs some more time. So currently, whatever students we have, which are doing those courses, doing those electives in that field, what I have found is that they do get placed. They work in a TI or in NVIDIA or Broadcom or Qualcomm, and then after a year or two, they all go to US. And it's me. I know who's going repo to them.
Yeah.
I know. So it is a kind of a brain drain for us, which really I feel very bad about it, but I can't do because everybody wants a good placement. Naturally, will
Absolutely.
that be possible to get reversed in near future?
See,
Will it be
I think
possible? Really,
the
is it possible?
some of the areas it's already started happening. So basically, I think the youth of any country will follow where the opportunities are, right? So I think traditionally for doing the masters some of these areas or PhD in these areas, US used to be the destination, and if you want to do startup or basically your own companies, right? There were few opportunities available in India, but I think that is very fast changing, right? I see that is already happening in the software. Uh, People are basically wanting to join the Indian software startups, then going to the US after completing their basically graduation or basically whatever degree they are doing, right? So I think we need to have the similar kind of success stories in the electronics and semiconductor also. Means, for example, right, our own graduate Samay Kohli, right? Basically, they created a wonderful company called Grey Orange, right? So we need more such examples so that basically people see there is ample of the opportunities there. I think there is no magic to it. Youth will always basically follow where the opportunities are. And if we are able to create those opportunities for them in India and create a lot of successful role model companies, right? They'll always be basically very interested. And I see today may not be that much in the hardware and semiconductors, but in software, I think we have very good ecosystem of the bits students and bits alumni, right? So I think it's changing. Maybe it will take another 5 to 7 years to get to a point where we will start basically uh, declining the brain drain part of it, and it will have a negative growth going forward. And I'm seeing that already happening. Uh, I think we are just at the cusp of that making it happen. Right?
Thank you, sir. And very thanks, sir. Thanks for you assisting us in conducting that video conference. So, I think we all students also know that we are conducting a VDAT. VLSI Design and Test Conference from 28th September to 30th, 31st. And I think that will be a good exposure to our undergrad as well as the graduate students. That would be really good, ma'am. Thank you.
Looking forward, ma'am. Okay, Kush.
Yeah. Others can proceed. Who wants to ask? Yes, Sanidhya, you can go ahead.
Good evening, sir. My question to you is, if I complete my bachelor's from electronics and communication or some allied fields, and if I do not go for any further degrees, am I more likely to land a blue collar job or a white collar job? And what will I need to do? What degrees do I need to take other than an MBA to convert that blue collar job to a white collar one?
I don't think any BITS graduate from any degree is going to go to white blue collar job. You are all going to get white collar job. I think if I talk about electronics and semiconductor, uh, as I was saying earlier, whichever branch you are, but if you do 4 or 5 courses, basically as elective or as a core courses, right? I think that is basically gives you enough foundation to work in any global semiconductor company, right? And I named some of these courses, and I think those are anyway 2 or 3 of are covered in your EC courses, and 2, 3 you can take as elective, and you will get a very basically good job, which is good from the content of the work as well as a good on the compensation part also, right? So I think slowly it's becoming not necessary to do a MBA or masters or PhD. It's good if you do, but I think there are ample opportunities for a good tech students to basically join those.
And so, what if I wish to join electronics and communication, and like that is the field that I'm interested in, but I have mistakenly landed up in an unrelated field? So how do I jump from?
Sanidhya, you are not audible.
Oh, okay. 1 second.
Only there's a lot of noise on
Sanidhya,
your
there
side.
was a lot of disturbance. Please repeat the question.
Is it better now?
Yeah.
Yeah, much better.
Yes. So what if I do not happen to be in fields like electronics in college, and like I have landed into another branch, say chemical or something, and I want to first get placed by companies of electronics and those fields directly after my bachelor's. What field, what path should I take in?
So I think first of all, semiconductor manufacturing requires the people from all the branches, not necessarily electronics, because a semiconductor fab is more like a chemical factory than an electronics factory if you look at what goes inside it, right? It makes electronics, but all the processes and everything is more chemicals and gases and automation and all those things. So that is almost given, right? Uh, for others who want to go like typical chip design type of the projects, as I said, if you do about 4 to 5 good courses, right, during this thing, and I think somebody had just raised their hand, can we list those courses, right? So for a non-electronics triple E or EC person, there may be about 6 courses, but for basically triple E guys, it might be 3 to 4 courses, right? If you do those courses, I think you will be very well uh, uh, covered in terms of basically getting into the industry. It obviously depends on how well you do those courses and how well you learn the fundamentals. But I think that is kind of like give you a good foundation to go and work in the industry.
Thank you so much. That was very helpful. Thank you.
Shankha, you can go ahead.
Good evening, sir. Can you hear me?
Just give me a 30-second break. Let me connect the power for my laptop. Give me a second.
Yes, sir.
Yeah, we can continue. Sorry about that.
Yes. Good evening, sir. You can hear me,
Yeah.
right? Yeah. So you brought up the point that a master's and a PhD is not really required, not a necessary factor nowadays for entering into industry or for pivoting from one role to the other. However, research experience is very heavily favored. So we have CD right here in Pilani itself. So what kind of opportunities can we expect from to get from CD? Like I'm a fresher, I'm in my first year. So what can be a how do I approach the CD and my professors, and how do I go about doing that? How do I go about gaining research experience in my undergrad? Something like that.
I think better than me, maybe
Hey,
Professor
Anand,
Anu will answer this question, right? So, but
yes,
ultimately, see, I'll give a high level answer and specific to bits, ma'am can answer. Uh, you need to pick up a problem which is interesting. Okay. Do your own research. You have a lot of tools available to you, internet, basically large language models like ChatGPT, Brad, Bard, and all of those things, right? So I think find an interesting problem, do some basic research, go to basically any professor in BEDS or Siri, and basically see how you can uh, get them to buy into what basically you want to do. And I think that once they understand the value of what you want to do, they will certainly support you in the research. And industry people also can help and support once you reach out to them. So one other thing I wanted to mention is to connect uh, all the Bitsians, present, past, and ancients, right? Uh, who are connected to semiconductor domain. I just created a LinkedIn group, Bits for Chips, right? I think all of you should see if you want to join that group so that you can be connected with other professionals basically in this area which have the bits pedigree. And whenever you have things like that, first of all, you have to identify a problem, right? Nobody is going to give you a problem hands down, right? If you want to do research, you look at an opportunity, you may not know the detail about how to solve that problem, but you need to identify the problem. I think beyond that, basically all of us are there to help. Your first line is your own professors in the bits, then you can go to Siri, then you can come to any of us in the industry. Uh, I'm always basically available to answer any question on the LinkedIn. Please connect so that basically anytime you have any queries like these things, you can reach out to me. And basically, I think in it may not be immediate, but within 2 to 3 days, I'll certainly respond to your question.
sure. Cleared up a lot of stuff
Let me
here. Thanks.
add to that. Like you are a fresher, Sankha. Am I talking to Sankha?
Yes,
Yeah.
yes, yes.
See, you are a fresher. I think you must be in your first semester, right?
Yes.
Hello.
Yes, ma'am.
So you first I will ask you to do your fundamentals, your core courses, right? Do them well, and from second year onward we have project-type courses, right? So you can get in touch with us if you meanwhile you keep on searching, exploring. If you identify a problem, you can always come to us. In case you feel that you are not able to find a problem, somehow you are getting stuck, even then together you can always contact us, right? I can say that I am always available. If you have something in mind, you can come and talk to me, right? then we will discuss in what direction you want to move. I have some projects with me on which my students are already working. Maybe if you have your own problem, then we can start working in that direction if it is interesting. We can tweak it a little bit, right? So I think all those project-related courses, your shop, your doc, your course, they are meant only for this purpose only. Okay?
Okay, ma'am. Sure. Thank you.
And one more basically information you guys already might know, but one of our basically esteemed alumni is donated large set of money to start a semiconductor COE at BITS, right? Which is a collaborative effort across all the campus. His name is Dr. Trehan, and we will be soon basically starting the activities under this Center of Excellence for Semiconductors uh, through the generous endowment which Mr. Trehan is given to BITS.
So Siddesh Patil in the chat asks, according to you, how big is the role of RISCB in this picture for India? Any insights you would like to share?
Huge. See what the RISC does, right? It completely democratized the processor design, right? For example, the Sanka was asking, what can I do? Okay. He can pick up basically a very simple RISC design and basically learn the things by reading or basically through the help of professor. And within the 6 months, basically he can design his own processor. Okay. So now if a second year student or first year student can start working on designing this processor, right? That completely opens up the field, right? Uh, and it helps in basically developing a lot of customized processor for customized applications rather than basically one or two or five or 10 companies monopolizing this thing, right? Any of you can pick up the basically RISC architecture and start designing on your own. There are a lot of resources available within the beds, within the community. The government has basically this program called DIR5, Digital India Risk 5 program. Okay, so they are also putting basically lot of effort through these things, and other organization uh, through VLSI Society of India, which I volunteer my time with, right? We are also going to start basically activities in the Risk 5 and anything else. Uh, you want to jump into it, you can contact any of us or any of your professors there. But I think for India, it could be a huge opportunity because we don't have to basically follow the same model of basically x86 or ARM. We can create a basically new set of processors, new set of entrepreneurs around the RISC-V architecture. But again, it's not the RISC-V which is important. It's the problem you want to solve using RISC-V that is important, right? So as I was basically answering Sankha, right? I think you need to identify interesting problems for which you can design the chip, right? And when you design the chip, you can choose RISC-V as your basically processor platform. And there are a lot of resources available in India to do this. CDAC, IIT Madras, so many other basically this thing, RISC-V International. We can basically help in whichever way. But I think if somebody in an undergraduate program can design and tape out a RISC-V processor, I think he would have covered all the courses, right? All the things which we need to basically learn in one another, what we learn in digital electronics, what we learn in computer architecture, what we learn in basically SoC design, everything would have been covered if you can design and tape out basically a RISC-V processor. And my I cannot give a concrete announcement, but within 6 months, we'll come up a goal which basically there will be 100 tape outs every year on the RISC-V from India. We are working on a program, but we'll come with an announcement where basically at least 100 institutions and practically if you basically create a group of 3 to 4 people, you can do it in 2 semesters.
Hopes that answers your question, Siddesh. Anyone else who wants to ask their questions to sir? Anu ma'am, you still want to go?
Pardon?
Do you want to ask her something? Your hand is still raised. That's why.
No, it's okay.
Acha,
From
okay.
Probably will not take it down, right? There is some question
Some,
from Chris.
Krish, you can go ahead.
Good evening, sir. I'm Krish.
Okay.
I'm a fresher this year. So I wanted to ask you, how do you see quantum processors and quantum chipsets affecting the chipset market here in India?
The quantum will be very big, but it will not. It will have its own basically area of influence. It will not basically influence everything which we do in the semiconductor, but the class of problems which you cannot basically solve very easily using the digital electronics or analog electronics, which the quantum computer once they reach some scale, right? We are talking about 64 bits, qubits, and things like that right now. Once they achieve a decent scale, they'll be able to solve the class of problems which are not easily solvable by the basically typical digital methods. But just like AI, it's not a replacement. It will create additional capabilities which basically uh, help us in solving some of the tough problems which we have not been able to solve using the typical digital electronics or computer science, right? So,
Right, sir.
so things like very specifically, we have these problems which are exponential complexity or what we call in computer science lingo NP complete problems, right? Traditional computer science cannot solve those problems. So we approximate the solutions to these problems, but quantum can solve these problems in a very reasonable time. So I think those kind of the effects will be there, but probably we are about 5 to 10 years away from basically quantum being realistically start using for these problems. Initially, it will be used for very large problems which are uh, important for the world, and then slowly it will percolate to more commercial problems. But again, it's not a replacement, it's just a basically another tool in our arsenal to solve the global problem.
Yes, sir. And sir, since it's not a very popular topic right now, how do you suggest I should get more information and more insights about this? Like, what are the different sources that I should be looking at?
Internet, ChatGPT, Bard,
Okay.
Quantum Mission, India is India Quantum Mission. You can go to that website and check it out. What we are doing basically, different initiatives. Uh, but I think for these new topics, your own initiative is the biggest tool, right? I think
Yes,
the information is available. Your own initiative is what is required.
right, sir. Thank you.
Tanedev, you have a question?
Yes. So I have, I am currently in chemical engineering, and my basically my aim is to get into the electronic side, and I find two types of people regarding when I ask advice. One group is like basically you can jump from any field to any field and the degree really doesn't matter. And the other one is like more of a conservative approach, which is like if you are into chemical, then you cannot really make that jump. And I wanted to ask, if I do my bachelor's from chemical and get into my master's for electronics and communication? Is it hard, or is it like, do I struggle more than the other people who do
No, it's
already
not
have?
hard. During your undergraduate, try to do, as I said, about 4 to 5 electives from the basically electronics or VLSI design side. You'll be very well prepared for the MTech. I don't think it will be challenge as long as basically there is no logistics hurdle that basically how do typically people get into MTech program through the gates and all those things. So as long as they don't create any obstacle, technically I think it's not tough.
Okay. Okay.
But you
And
need to take about 4 to 5 courses during your BTech program, right?
yeah,
To
sure.
basically clearly understand.
I was just looking at your profile on LinkedIn, and first you went from electronics to computer, and then like the progression seems to be from electrical to IT side. Like at the end, like your final degree, what I can see here is about neural nets, which is still with that not something everybody knows about. So what was like your, what was the basis of all these decisions that you were making with regards to your degree or your career? Like what were you deciding based upon?
Yeah. We talked about it a little bit in the beginning, but BITS was obviously triple E. Then IIT was more of a computer engineering, not computer science, which was very much related. And I was also involved in a basically sponsored project to basically work in the semiconductor area as a project while I was basically doing a master. Similarly, PhD neural network first 1 year, whatever spent, it was not that much on algorithmic side. It was that how we can use basically the latest computer and latest architecture from the both chip design and computer for realizing the potential of the neural network, which is the basis of ultimately all the AI algorithms, right? So that's how it went. And then I joined Intel in the supercomputing division, then moved to processor division, and then last basically 30 years is hardcore chips, right? So that's how it moved. So name it sounds might be more like IT, but actually it was computer engineering and uh, processor and computer architecture for AI application, not AI from an algorithmic side. Right?
I see. I see. So basically, you were being driven by your interests.
Yeah, typically, basically, uh, chip design, high performance computing, all of those things, right?
Thank you so much.
Anyone else with a question for sir? Okay, it seems like sir you have answered all our queries in a great manner. With this, we come to the end of the talk. On the behalf of whole BITS Embryo team, sincerely thank Dr. Gupta for all the knowledge he shared and insights in the world of semiconductor. I'm sure all of us learned something. I did, in fact, a lot. Uh, BITS Embryo strives to conduct more of these talks which are aligned with your interests. And if you have any suggestions for us, you can drop them in the Google form from our Instagram page. You can a feedback form will be shared in the chat. It would be very kind of you to fill it for us. Thank you and have a nice evening ahead. Once again, thank
If
you,
any
Dr.
of you have any question, any help, any advice needed, please do connect on the LinkedIn and drop a message. We are always there to basically help you out. And end of September, join VDAT. I think we can meet in person that time, whatever it is. But anytime, any question, always there to help out. So join on the LinkedIn where you can reach out. Uh, Thank you so much. And I really enjoyed talking to all the fellow Bitsian and also join this Bits for Chips, basically LinkedIn group, so that we can all be connected.
Okay. Thank you. Thank you so much, sir.
Thank you very much. See you in Kilani in end of this September.
Yes, sir. We all look forward to meeting you as well.
Signing off.